Chemistry, Unit 4, Organic Nomenclature. So here we officially launch into the organic part of VC chemistry. And before we do anything else, we need to learn how to name the organic compounds using IUPAC naming system. The study design requires us to be able to name organic compounds with no more than 8 carbons in their main chain. Okay? And the functional groups that we need to name are hydrocarbons. They are non-cyclic ones, so chain hydrocarbons, haloalkanes, primary amines, alcohols, carboxylic acids, and non-branched esters. You will see that there are only 2 functional groups, haloalkanes and primary amines, that are new to Year 12 chemistry. Okay, so I want you to treat the rest of this section as a revision from Year 11. Now, straight alkanes, quite straightforward as the name indicates. They are stem name plus A and E. Okay? So what are the stem names that we must memorize? That is basically the set of letter codes referring to a particular number. Okay, so when I say pent something, I mean there are 5 carbons. When I say hept something, I mean 7 carbons. And from 1 to 8 are those stem names you must memorize. They are not on your data book. For example, here we are looking at 5 carbons. 5 carbons means pent, and since there are no other functional groups, it's an alkane, so it is a pentane. Sometimes you will see a skeletal formula given to you. In skeletal formulas, every term is a carbon atom, in this case, all saturated carbon atoms, including both ends. So here we're looking at 1, 2, 3, 4, 5, 6, 7, 8 carbons, and therefore it is a octane. So skeletal formula, every turn is a carbon, including the ends of the chain. Sometimes alkanes can have branches. And in that case, 2 different molecules can have exactly the same molecular formula, but they are actually 2 different molecules because they have 2 different structures. Those molecules, we call them isomers. So alkane isomers could represent themselves in this way. See, both molecules will have 5 carbons in their entire molecule, but structurally they're very different, and therefore in terms of some kind of chemical reactions, they will react in a very different way, and therefore we must distinguish them. In terms of molecular formula, they're the same, they're C5H12, but when we use IUPAC naming system, we are able to tell the difference. So how do we use that? First, we need to identify the longest continuous chain of carbon atoms. In this case, this molecule on the left will have 4 carbons. That is the longest continuous chain. But the molecule on the right-hand side only have 3. However you count it, there are only 3 carbons in that makes up the longest continuous chain. Okay? And then identify any alkyl side chains. You'll notice that for the molecule on the left, this is the side chain. But here, if you count the middle 3 carbons as the main chain, then you have 2 alkyl side chains. 3, then we need to number the carbon atoms in the chain to give the lowest number to attachment points. That means that instead of start numbering on this side, we need to start numbering on that side, on the right-hand side for this molecule, so now your alkyl group will be on the 2nd carbon. That is the lowest position number that we can give. In the end, you need to name the isomer. Okay, so how do we do this? First of all, identify the longest continuous chain. That is here. Okay? You have 6 carbons. However you count it, this will be the longest continuous chain of carbons. Then if this carbon does not have any other side chains, it will be called a hexane. So the main chain is a hexane. Then identify the alkyl side chains, that is, these three. You'll notice that there are three side chains. Two of them have one carbon and one of them has two carbons. Okay? For those who have two carbons is eth, so they're an ethyl group. One carbon is meth, so they are methyl groups. Since there are two methyl groups, we gotta call them dimethyl. Okay, so ethyl, dimethyl. Okay, then we gotta number. Do we number from this side or that side? We need to number from the side so that we give the lowest position number. So these two side chains are attached to the lowest position number of carbons. So second is much better than if we number from this side. It will be 1, 2, 3, 4, 5. Okay, so 2 is better than 5. We have to keep the position number of side chains the lowest overall. Okay, and therefore our position would be 2, 2, and this guy is on the third carbon. So it's 3-ethyl, 2,2-dimethyl. But why do you put ethyl here and methyl there? Because for the name of the side chains, we need to put them into an alphabetical order. So E is before M on the alphabet, therefore ethyl before methyl in the name. Also, you'll notice that when there are more than one side chains, one of the same side chains in the entire molecule, then we have to add di, or some cases it might be tri or tetra. Okay, and overall, no spaces. So for alkanes, strictly there are no spaces. Between number and letters, we continue them with a short dash. Between numbers, we separate them using a comma. But overall, no space. Let's do more practice. So in this case, you will have 6 carbons in the longest continuous chain. And we number from the right-hand side because in this way, we give the side chains the lowest position number. And in that case, we are looking at a 2,4-dimethyl hexane. Here, we already see the name. How does the name come about? We need to first identify the longest continuous chain. In that way, it's actually this guy. So if you think the longest chain is the horizontal one, then you got it wrong. Okay, because obviously you gotta find the longest carbon chains that are continuous. So sometimes they can have a twist and turn. Okay, so you have 9 carbons. That's why they're non-name. And then out of these 9 carbons, we have 1, 2, 3, and 4. That is one carbon side chain. That is a methyl groups. So since we have 1, 2, 3, 4, it's tetramethyl group. Where are they? They are connected on the 3rd carbon, 4th carbon, 4th carbon, and the 6th carbon. So the numerals are the positions of those side chains.